Good afternoon, everyone. Srinivasan sir, I think your audio is not connected. Good afternoon, everyone. Science is a process that takes us from confusion to understanding. I welcome you all to the 107th episode of our Creative Weekend sessions. I am Sai Madhuri, hosting today's episode. Creative is a team of like minded people who are enthusiastic towards gaining knowledge. CRE stands for creativity, active stands for activeness. Together, we are creative. Creativity and activeness gives us pleasure. Knowledge Square is our tagline, says that construction of knowledge takes place when it is shared. Our creative vision is to share knowledge and double it. We are focusing on non-textual, non-academic, and non-syllabus concepts. I would like to thank all our resource persons on behalf of all the participants who accepted our request and presented their talk in our weekend sessions. Every Saturday, Creative is organizing a talk in a Zoom platform and live streaming it in our Creative GBD YouTube channel. Today's 107th talk is on LVM3M4 Chandrayaan-3 mission by Shri M.S. Srinivasan, former Group Director, PSG, URSC, ISRO. To introduce today's speaker, we have Ms. Divya, Creative Volunteer. Over to Divya.
Thank you. Good afternoon, one and all present here. I am Divya, volunteer of Creative. I am here to introduce our today's chief guest, Mr. M.S. Srinivasan. He is a former group director, PSG, URSC, ISRO. He joined UR Rao Satellite Center after BE Electronics from UVCE, Bangalore. He has guided and executed various satellite programs, has designed engineer, section head, division head in battery division, and group director for power system group. Involved in power system configuration for all ISRO satellites from nano to high power LEO remote sensing and geo communication satellites. He has expertise in design, analysis, fabrication, and testing of various batteries to all satellites built by ISRO. He has vast experience in onboard power system, health monitoring, and management of various LEO and GEO satellites. As Group Director of Power System Group, has been responsible for the configuration of new power electronic systems in LEO and GEO scientific mission and human space program. This is all about our chief guest. I am welcoming you, sir, for this session. And I am welcoming all the participants of Creative. And I am welcoming all the volunteers and Creative. And thank you, Akka, for giving me this opportunity.
Thank you, Divya. Now over to Srinivasan, sir.
Yeah, good afternoon, everybody. It's nice to talk to children and other people who are interested in a major event which is going to happen this week. It's a major scientific event being done by India. I'm seeing more than 100 people have already joined, and it's good to see so much interest in science. I remember in Chandrayaan-2 happened, people are like watching like a cricket match. They were awake overnight and were waiting for the landing to happen. Unfortunately, we went up to 1.5 kilometers. We traveled more than 4 lakh kilometers. Just little short of moon, we could not land. And this time, all improvements have been done. A lot of redundancies have been built. Lots of testing has been done, and ISRO is confident we'll have a successful landing on July 23rd at 5:47. All of you, please look forward to that. Now I'll give a brief introduction about rocket, that is the GSP Mark III, which is being used for this, which was used for this launch, and Chandrayaan-3, how it was built, what are the features in this, what are the experiments which are planned to be done by this different payloads on both lander, rover, and also propulsion module, and show some videos and how the satellite is built, those things. So other people can mute their mics and switch off their camera also, so that the bandwidth is better. Now I'll share the screen presentation. If any questions are there, please note down, and at the end of the lecture, we can answer all the questions. Is the presentation visible?
Yes, sir. It is visible.
Yeah. So now, what you are seeing on the, 1 second. Other people can switch off the camera so that bandwidth will be better. So this is the Chandrayaan-3 third mission to moon. We had Chandrayaan-1 in 2008, Chandrayaan-2 in 2019, and this is the third successive mission to the moon, where India was the first country to detect water in 2008 using our Chandrayaan-1 payloads. And everybody thinks if humankind has to go to other planets or any asteroid visit, anything, this will be a good launch pad where you can have a base on the moon. From there, we can go to other planets. Yeah, what you will see is the GSLV Mark 3. Actually, this will be used for our next year. We are going to have Gaganyaan project where we are going to put Indian astronauts into space. So this is a human-rated rocket where lots of safety features have been built in, and before actual flight, we should have a three consecutive successful flights. So this rocket has been is a heavy-duty rocket from India, which can take our Gaganyaan astronauts to space. So here you can see this is the rocket. There are 3 stages in that. There are 2 strap-on boosters. What is on either side of the rocket? I will show the model also, small model. What you can see here, these 2 are the solid boosters. The middle one is the liquid stage, and this is the cryogenic stage. And top we have the satellite. I will show how the satellite is integrated to that. On the right side, you see the propulsion module. So why you are using propulsion module is in Chandrayaan. Pranami, you can switch off your camera. So already our Chandrayaan-2 orbiter, which was designed for 1 year, it is still working fine. So this time we wanted to have more fuel, more solar power generation, so more weight to the lander and the rover. So this time that orbiter, because the Chandrayaan-2 orbiter is still working fine, it will work for another 4 more years. This Chandrayaan-3, we have a propulsion module. The work of this is to take the lander to the moon's orbit. So that is already done. So this will have only 1 more payload that I will come to that later. So now we'll go to the different phases of this Chandrayaan-3 mission. First, we have the launch, so Earth-centric phase, where we have the pre-launch phase. Then we launch the rocket. There is a launch phase and ascent phase. Then Earthbound manners. So satellite will be going around Earth in several apogee firings. Somebody will ask why we can't use a powerful rocket. I will come to that later. Then we have a transfer trajectory phase where we give more velocity to the satellite so that it goes close to the moon. Then after 4 days, when it's close to the moon, we have a lunar orbit insertion. This is a very others can mute please, where it's a very critical phase. And India, 4th time we have successfully done the lunar orbit insertion. So in fact, even countries like America, Russia, and all could succeed only their 8th or 9th attempt, whereas India has successfully done in Chandrayaan-1 mission, Chandrayaan-2 mission, Chandrayaan-3 mission, and Mars orbiter mission also. This is a very, very critical phase. Then subsequently, we have the moon-bound maneuver phase, where we reduce the orbit and go close to the moon. Then there is the deboost phase, where the lander is brought close to the moon. Then we have the landing phase. Then normal phase of lander and rover, where the experiments will be carried out over 14 days. Then this propulsion module.
Sir, please unmute yourself, sir.
Oh, sorry, I was not heard.
Yes, sir, you can carry on.
Yeah, so this is the planned mission. So now we have already done the separation of propulsion module and the lander module. one deboost operation was carried out yesterday. One more operation is planned tomorrow. And then Monday, one more, it will be brought very close to the surface of moon on Monday. Then on 23rd evening, we are going to have a successful landing of lander on the surface of moon. So people will wonder how the rocket is built. It's a long process. It takes about 2 months to assemble the rocket. What you see is the two strap-on boosters. First, they're brought and assembled in this is called a vehicle assembly building. Then this liquid stage is brought, that is put at the middle. So I can see either side of, you're able to see, first these two strap-on boosters are brought. Then this middle portion, this is called the liquid stage, which is brought. Then this is the cryogenic stage. Then one by one, they're all assembled. Then the satellite is built in ISRO Satellite Center, Bangalore, where it has different subsystems like power system, control system, sensor system, thermal system, structures, propulsion, thermal, like that. So all these things are done. Over a period of time, all are individually tested, then assembled and tested at ISRO Satellite Center, Bangalore. Then the satellite is transported to Sriharikota for launch-based activities. Then after that, it is some tests are done and it is assembled. I will show subsequent slides. Then the rocket is moved to the launch pad. This is what you would have seen on the launch day, where it is ready for launch. So you can see here, this is a human-rated rocket, LVM3. This is the rocket built by ISRO. There is a most powerful rocket built by ISRO. As I told earlier, it has two strap-on boosters and one liquid stage at the center, one cryogenic stage. And the satellite is sitting inside this. There is a heat shield here, which protects the satellite when the satellite is launched. So you can see the weight of this different, each phase is given here, height and dimension. This cryogenic stage weighs 28 tons. This core stage, this stage weighs is a 21 meters height and 4 meters dia. Then this solid two strap-on boosters are there. They weigh 205 tons. So inside the, and this is the lift-off mass capability. When the rocket is launched, it weighs about 642 tons, and height is 43.5 meters. Imagine it's about 120 feet tall structure when it goes up. And this is how the satellite is mounted inside. I will show the assembly of the satellite and into the heat shield. This outer one is called the heat shield. So this is the construction of Chandrayaan. So here this is called the propulsion module, and this is the lander. The rover is sitting inside. This is a ramp for the rover. Afterwards, I will show how it rolls out. And this is both are assembled one above the other and assembled into the rocket like this. These are the different views of the rocket. I mean, satellite. It's called pitch, roll, yeah, we call it, to identify the direction of movement. Then looking towards Earth and perpendicular to that. So then once it goes to the, once it successfully lands on the surface of moon, this is the ramp which rolls out like this. Then the roller comes up and then it does it express. I will talk to that. I will cover that later. So here I will show. Afterwards, I'll show the different models. So this is the rover. It is having a solar panel to generate power. It has 6 wheels. This function of that also I will tell. To all of you would have seen the footprints left by Armstrong on the surface of moon. Even though he landed in 1969, even though people can see it because there is no atmosphere on the surface of moon. So its footprints are even now visible by whichever orbiter is going around Earth. So once our roller rolls on the surface of moon, on the backside of the roller wheels, on this wheel pattern is there of an Ashoka emblem is there, and our ISRO emblem is both are there in the pattern of this. So this will leave a footmark on the surface of moon. I will show that video of Chandrayaan-3 where this is depicted. So you can permanently, it will be there for centuries to come. So this is the actual satellite image. You can see the solar panel on all sides to generate power. So it is not a odd shape. It's not a fixed shape because wherever required, we have to cut it. We have to reduce the margin, but still generate a lot of power. So wherever possible, solar panels have been put. On the bottom one is the propulsion module, and these 4, one is at the back side. These are the 400 Newton engines which will be fired to go and have a smooth landing at the surface of moon. And the rover will be sitting on this face. This is the ramp which will fold out. Then rover will come out after the dust has settled on the surface of the moon on the evening of 23rd August. So you can see here how the two things are separately brought out. This is the first module. Then this lander is attached to that. Then both are covered by heat shield. This heat shield is required to safeguard the satellite when the rocket is launched. So once we have atmosphere, the temperature will be very high. At that time, we have to ensure that the satellite temperature doesn't go up. The heat shield of the rocket ensures that the satellite is covered. Afterwards, these things are opened in orbit, and then subsequently satellite is ejected. I will show in subsequent slides. So now, as I told earlier, this is the vehicle assembly building where the rocket is assembled. In the previous slide, you saw how it is assembled. Then it's brought on a heavy-duty trawler. This is the launch pad. This is brought to the launching pad where this is the final place where it will be kept. And all around that, we'll be having lightning arresters and water quenchers, because when the rockets are firing, a lot of heat will be there. So a lot of water is put to reduce the impact of heat. So this is the final configuration where the rocket is launched. So these are the different phases of the rocket when it's launched. First, we have the two solid boosters. They are injected. You can see here on ground, it starts from 0 velocity. So when this two solid boosters are ignited, we are at a height of about 0.024 kilometers. And it initially starts with 0.45 kilometers per second velocity. Then after 108 seconds, this liquid stage is ignited at a height of 44 kilometers. Then the speed would have picked up to 1.794 acceleration. Then these two strap-ons are separated. It will go and fall safely into the sea in Bay of Bengal at 127 seconds. Then at a height of 61 kilometers. Then the velocity would have picked up to 1.977. Then the payload fairings, that is the heat shield, is removed. So at this height, the temperature would have reduced. So then this heat shield gets detached from the rocket. It will go and fall into the ocean. Then this cryogenic stage is ignited at around 307 seconds at a distance of 176 kilometers. And then velocity will pick up to 4.6 kilometers per second. Then it burns for about 650 seconds. So in that time, you can see the velocity has picked up from 4.6 to 10.272. So why I am telling it is, you see, we to go out of the gravitational force of Earth, you need to have 11.2 kilometers per second speed. But to achieve it, it will go out of gravitational force of Earth. So now we have to get into Moon's orbit, means we should get something like 10.8. So I will tell with limited resources, with low budget, unlike other people, we are able to take 4-ton satellite to Moon. So these are the first satellite is injected into Earth. It's about 180 by 36,000 kilometers. And these are called earth burns. Around the Earth, it will go around. It will have one burn. When it comes here, it will be going very fast. When it's going here, it will be very slow. These are elliptical orbit. Then by firing the engines repeatedly, first time, second time, third time, fourth time, then we would have gone to a height of about 1 lakh kilometers. At that time, one more time, the motors are fired to get a 10.8 kilometers per second velocity. At the time, the satellite is put into what is called a lunar transfer trajectory. So it will go up to Moon is about 3.84 lakh kilometers an average distance. So it will put into a long elliptical orbit. If Moon were not there, the satellite would have come back and come to Earth in 230 hours, about 10 days time. So this is the critical moment where the satellite is put into lunar transfer injection. After this maneuver, it takes about 4 days for the propulsion module lander to go close to the Moon. At the time, we have to get into the gravitational force of Moon. So that is a very tricky affair. So there we have to reduce the speed to almost 0. Then it gets into the gravitational force of Earth. Then it will put it in elliptical orbit, 173 by 1.7 lakh kilometers. Then slowly the orbit height is reduced in several manners. All these things have been done. And day for day, we have done this. It was put in 153 by 163 kilometers when it came that close. This propulsion module and the lander module were separated. Now the yesterday one more was done where the lander is brought still closer to the Earth. Here you can see here. So this 100 by 30 is only indicative number. So it is slowly brought in 100 by 30 elliptical orbit. Then slowly it will come and land. So that's the critical phase. I will cover that subsequently. It will have a smooth touch down on the surface of Moon on 23rd August. So here you can see the what I was telling. So the Earth is moving like this. Then the after injection, the satellite is moving around Earth like this. Then it goes to the surface of Moon. Actually, the speeds are not same. It is only indicative speed is shown, so that it is not so fast. It is slow. Then the satellite goes round and round and goes close to the surface of Moon. Finally lands. So you will be wondering why you all would have heard of this Shukla Paksha, Krishna Paksha, no? Full moon day, new moon day and all. So here you can see why it is happening here. Earth goes on its own axis in 24 hours daily, and it takes 365 days to go around Sun. Whereas Moon takes about 28 days to go around Earth. You can see here, this is the surface of Earth, which is facing the Sun, and we are getting light. Almost 50% you can say light, Sun and day. So when the Moon is getting the sunlight from here, it is visible from Earth. That's why we are able to see the surface of Moon when in this portion of the Earth. When it's here, you can see the sunlight is not falling on this surface. So that's why we get Amavasya. When the Moon is here, we get Amavasya. And when we will see the Moon going up, slowly increasing. Here is the Hunnime day where we see full Moon. Then it will be waxing Moon. It will go on reducing. Then again from here onwards, it will go on reducing. And here we have the Amavasya. So here, this is how we get this Krishna Paksha, Shukla Paksha, or Hunnime and Amavasya, because the Moon takes about 28 days to go around Earth. So when the Moon is here only, we can do experiments because the power is generated only when the sun rays are falling on the lander. So our mission goal is to have a 14 day. That is called one Moon day is 14 Earth days. From here to here, it takes 14 days for the Moon to travel. So this time it will be getting sunlight. So during this time, our lander and rover will work. Then when it comes here, the Moon will not be getting sunlight. So another next 14 days, there will be no power generation, and the lander and rover will go off. So our mission life is 14 days when the Moon is traveling from here to here. That's how we are landing on 23rd. That's the beginning of this cycle. And if 23rd we are unable to land for whatever reason, one more spare day is kept 24th. We'll land on Moon on 24th August. Then next 14 days, satellite will be working, and we'll be able to do all our experiments planned. So after this, as I earlier told, this lunar insertion operation was done. Then we, as I told earlier, we have to reduce the speed to about 0.19 kilometers per second. Then only it will get into Moon's gravitational force, and it will be going around Moon. So afterwards, as I told earlier, several maneuvers are done to increase the speed. So you can see here, these are the events. First, it was put in 164 by 187 kilometer orbit. Then it was reduced to 4,313. Then 177 by 1437. Then on 23rd, we are going to further reduce this and bring it closer to the Moon, and then land it on the surface of Moon. So to ensure whatever lessons we learned from Chandrayaan-2, lots of things have been improvements have been done. One is the Chandrayaan-2 on-orbit experience. What was the missing factor in Chandrayaan-2? And Chandrayaan-2 orbit is still working. That is being used to communicate with Earth. And lots of ground tests and simulations have been done to ensure that there are multiple redundancies. And before testing it, everything is tested on ground. Lot of simulation tests have been done, and a lot of robustness is built into the lander. It's a factor of 3. Even if it's expected to land at about 1 meter per second, so the legs of the rover, lander, are built to withstand. Even if it lands at 3 meters per second, also it will be able to withstand. Then all this software, because to get a signal from moon to earth, it takes about 1.2 seconds. So we cannot do anything from earth. So everything has to be autonomous. So all the software automation has been done in the onboard computers on the lander. So everything will be done, and we'll be monitoring from. We have a Earth station at 30-meter dish antenna. It's called a deep space network, part of deep space network. That's at Bailalu, close to Doddaladmara. From there, the satellite is tracked by a 30-meter dish antenna. From there, we'll be getting the signal to track where our control center is there. And all experts in different fields, power, thermal, communication, controls, propulsion, like that, they'll be monitoring the data. And all operations will be carried out from there. So these are the improvements done in this Chandrayaan-3 guidance algorithm. It ensures the engine thrust is whatever the profile is there, it is following that. It will do a corrective action, and the thrust regulation logic is there. It will regulate the thrust. It is required to be reduced or increased. It will instantaneously take the decision without ground intervention. And perturbation, if any variation is there, also it will be able to absorb it. And we have backup plans also. Already after landing, I will show the video taken by Chandrayaan-3 lander upwards. So already this has been mapped where it is supposed to land, and that to check whether it is landing in the intended target region, and it will do the required retargeting to land at alternate site. If any boulders or any pits are there, we can't land. I will show the surface of moon. So people say Chandramukhi, no, actually it's not as round or smooth like that. There are lots of because many asteroids and all have hit the surface of moon, and even volcanoes also take place. That also we will be studying. So there are huge hills and pits on the surface of moon. So we can't land on a slopy area or on a hill or in a pit where sunlight doesn't fall. So all these things, real time, it will take a decision and change the landing site depending on requirement. And real time detection of electrical failure. If any thruster is failing, it will block that, isolate that to ensure that it doesn't over fire. So these are the additional new features built into this. There is a Doppler velocity meter. So it shows the position of it shows the velocity, how fast the lander is moving in all 3 axes, both vertical, all 3 dimensions. And there is a lander horizontal velocity. After I show when the lander will be moving horizontally with respect to ground, what is the height? It will take a photography and check that height also. And laser altimeter. This gives the height of the lander in the surface of moon. So it shows the height, at what height the lander is moving, so that it will be closed loop. We'll have a successful land. And there is a carband altimeter. So it will have a good communication with respect to it will ensure the communication. And there is a lander hazard avoidance camera, which will take the photograph of moon, and it will be processed. It ensures that it is not falling on a place where the slope is more or there's a pit or anything. And another one is the laser gyro based industrial reference unit and accelerometer package. So this has been a further improvement have been done compared to last time, and this is also present on that. So here you can see this is the swath, we call it, path of the moon. You can see this is the 11 kilometer by 55 kilometers. So this has been multiple times photographed by Chandrayaan-2 orbiter. So even this Chandrayaan-3 lander also has already photographed this. I will show the video which was taken yesterday. So in the Chandrayaan-3 lander, we had a very small region. It was only 0.5 kilometer by 0.5 kilometer a landing area, which was very critical. So in this Chandrayaan-3, what ISRO has done is the landing site has been enormously increased. It is 2.4 kilometer by 4 kilometer. That's a huge rectangular area, and it will launch. It will land on a place where there are no pits. You can see here. So we can't. If you land here, there will be no sunlight, or if you land here, it will not fall off because the slope is more than 3 meters per 3 meters. I mean 30 degrees slope. So it will find a suitable location where the surface is flat and we'll have a smooth landing. If it's unable to do for whatever reason, next day it will again do one more attempt. So as I told earlier, this landing area has been increased from 4.5 to 4.4 kilometer by 2.4 kilometer compared to 0.5 by 0.5 in Chandrayaan. So this landing site has been so many times because it is working since last 4 years. So this has been multiple times characterized. So we know every latitude, longitude, how the surface looks like, where the pits are there, where craters are there, where hillocks are there. Those places are avoided. Now, in addition to that, these data sets have been already stored in the lander memory, where this picture, it will do it will apply some intelligence to look for signature, how it looks like, and match the data with the data available stored on the lander taken by previous photographs. Then, after ensuring that it is in the intended place, it will have a successful landing, and it will look for hazard detection. Also, it does. If slope is greater than 10 degrees and crater is greater than 1.2 meter crater is there, or if there is a boulder more than 0.28 meters height and diameter of greater than 1.2 meters, all these reasons it will avoid. You can see here these reasons it will avoid. It will ensure where there are no boulders, no pits, and slopes are small. So we have a successful landing, and the rover will have a good surface to do its intended experiment. So these are the further improvements done in Chandrayaan-3 lander. One is the structure. It has been increased to withstand much more loads. All the margin of safety has been increased. Thermal, there is a thermal control has been improved for this LVM sensor, and mechanisms for the expand transport. There is a motor which is required for communication, that is also done there, and this data rates have been enhanced from 1 to 4 kbps, and there is a redundancy also included, and power. And on this lander, the power generation has been increased by having a larger solar panel area, and the battery capacity has been also increased from 3.5 to 63 ampere hour. So all these things gives a lot of redundancy and lots of margins in case of plan A, plan B, plan C, like that. And the propulsion also, the fuel also has been increased because our whatever was reduced in propulsion module, that has been added to the capacity of lander. So lander fuel also is more, so that we have a alternate plan in case the landing place is not correct, is good. So this reaction wheels and the wheel drive electronics, they also have been improved to improve the performance. So, and all these things, one is the design aspect. What I told is the design where the performance, all improvements have been done. Now we need to test these things. So these things have to be validated on ground first, before launching the satellite. So all these things have been done at Eurosector Center. We have a campus in ISRO Marathalli. All these tests have been integrated tests have been done, and there is an ISRO station at Chitradurga. There also the propulsion module has been taken by a helicopter, and tests have been done to assess the different sensors, propulsion system, the guidance control electronics in closed loop, and whether to check whether all sensors are operating properly, and it helps the engine firing condition. And the integrated hot test. This test was done at Srivikota, where the propulsion module is hung using a big crane. You can see here this is the crane head. The lander is hung on that, and the engines are fired to test. It is able to all that guidance control electronics is working fine. So now coming to the communication, the Chandrayaan-3 lander, it is having various communication modes. As long as it's propulsion module will be directly communicating. This is the D space network I was talking about, which is in Bailalo, Bangalore. The 30-meter dish antenna is about 100 feet diameter, you can see. So this when the lander is along with propulsion module, this propulsion module will be communicating with Earth. Then once it lands on the surface of Moon, it is once the rover is released, rover is having communication only with the lander, whereas lander has having communication with the Chandrayaan-2 orbiter. That in turn can receive signals and send signals to data to this deep space network antenna directly. Also, the Chandrayaan-2 can communicate through this ground station also. So we have multiple paths, multiple redundancies to ensure the data is available all the time. This Chandrayaan-2 orbiter is looking at lander. Chandrayaan-3 propulsion module also is looking at lander, and they are able to communicate with Earth. So we are having multiple data sets, multiple redundancy paths to ensure everything goes smooth and continuity is there in getting data. So this is the same thing, RF communication, which band is happening, S band, X band, like that. Then this all the payload data is transmitted through X band. So redundancy is in data transmitter. So only rover communicates only with the lander, and in turn lander will communicate either through orbiter or directly through deep space network antenna. So this shows the explored view of the actually what you saw earlier is the finished product, where actually you can see here, this is the, you're able to see, this is the image of lander, this is a paper module. So this is what you saw. Actually what goes inside this is shown here. There is a central cylinder where the propulsion gas cylinders are kept here. Then all the different elements are separately brought, and there are 6 phases to the satellite. You can see here 1, 2, 3, 4, 5, 6. So each phase different operations will be carried out, and before bringing it here, they are individually tested, like power system, thermal system, control system, propulsion system. Then first the structure comes. All these things are integrated into the structure, then assembled. Then all these detailed tests are done. This is the image of the lander. These are the propulsion module looks. So when it is going, it will be sitting one above the other and going around Earth. Let's say this is the, you see here, no, this is the Earth, means it will be going around Earth. So once it goes near Moon, so this is the surface of Moon, it will be going around Moon. Then these two will detach. Only land will be going around Moon. Then it will have a successful landing on the surface of Moon at the end. So what is planned here is, this is the, you can see image of Moon, where on the close to the South Pole landing area has been identified, because all other people, including Armstrong and other Americans, know so many times they went to Moon. So they landed close to the equator of the Moon, whereas we are planning to, even Russians are planning to land on Monday. So we'll be landing on Wednesday, because the sunlight starts from 23rd. That's why we can't land tomorrow. If it were sunlight were falling, we could have landed on 21st also. So close to the South Pole, where we have found traces of water, possibility of life is possible there. So lots of experiments are planned. I will come to those things later. So it will come and land on the surface of Moon at this place, close to the South Pole. Then once it happens, this is the rover, which will, there's a ramp will be there, and it will roll out and come down. Then it will go on the surface of Moon. It will be visible all the time to the lander, and it will do experiments, will communicate to lander. This in turn will communicate to Earth using the antenna through Chandrayaan-2 orbiter. So as I told earlier, this is the ramp. First, this ramp will go about landing. Then this ramp will come down. Then this rover will be attached here. Then it will come down. Then the solar panels of that are deployed. Then the rover is released. It will go down, and it will go down from the lander, and it will do lots of experiments and get the scientific data to lander. From here, it is communicated to Earth. So these are the glimpses of the different hardware which are assembled. Swap pans are here. This is the main antenna. This is the rover picture. Then the rover some tests are. These are different phases of. Again, the different tests are done in integrated mode. How it is handled using a crane. And this is the test done at Sherikota, where it is taken and hung using a crane, and tests are done. So this is the different special tests which are done to validate all safety measures. I mean, readiness are built in. Extra care is taken to ensure we have a successful landing this time. Some more tests which was taken by helicopter tests which were done at Chitradurga. These are the tests done at Sherikota, as I told earlier, to assess the integrated performance of the propulsion system, sensors, guidance, control, electronics, in closed loop. Everything has been verified and validated. And this is the lander leg design on touchdown. So if this falls very fast, this lander leg, if it breaks, then see if this is the lander now. If one of the legs fails, then it will topple. So that we have to ensure the legs are strong enough to have a smooth landing on the surface of moon. So if this is the surface, you should have a proper landing. If one leg doesn't, if it breaks, then it will fall off. So here a lot of readiness, this structurally has been improved and is designed to withstand, even if it drops at 3 meters per second also, it can withstand the shock when it lands. Even though it will be brought down below 1 meter per second, sufficient margin is ensure it successfully lands on the surface of moon. So this is the test I was talking about, this lander. So it is designed to withstand 3 meters per second touchdown speed. Actually, the velocity will be less than 1 meter per second at the time of landing. And a lot of margin has been built in. Even this, when it touches down also, the specification is even if the slope is 2 meters per second, when the touchdown speed. So vertical velocity, it will be brought to below 0.5 meters per second, and horizontal velocity less than 12 degrees. So this has a lot of readiness is there, and robustness is there in building this lander. So this is how a crater on moon looks like. So near Tamil Nadu, some place this type of sand is available, earth, which is very close to the surface of moon. So like this, one site has been prepared at our Chitradurga campus, Challakere, and this surface has been, this crater has been created here, and the lander is taking the helicopter to see whether it is able to detect this crater. It should be able to do a 3D profiling of this and find out the slope, whether it's flat is there or there is a hilly region, all those things. These tests have been, and you can see here, this is the helicopter to which the lander was taken, and this lander was kept inside this module, was taken to a helicopter, and this test was done. This is the landing area where this tests were performed. And this is the other one where Sherikota, this test was done, where it's taken a big crane, and these engines are fired in a closed loop to check all engines are firing. If one engine doesn't fire for whatever reason, what to do, control electronics, how to take care, everything has been done in this. So now I'll come to the remaining phases of moon. Now the separation of propulsion module lander has been completed, and slowly the lander is brought close to the surface of moon. Already one maneuver was done yesterday, and tomorrow one more will be done, and it will be put into final 100 by 30 kilometer orbit. Then finally it will go and land on the surface of moon. So this is the thing. Once it comes to 800 meters, it will be hovering here. Then it will further come down, and it will look at the target where it should land and do required correction, and go and land there. So this is the power descent. This is the critical. So we had a problem in Chandrayaan-2. This phase only we had problem. We went up to this phase, where from here only it did not follow this profile, and we had a we didn't have a soft landing. So these are, as our chairman told, is the critical phase where rough braking. So the satellite will be going at 1.8 kilometers per second speed. It has to be brought to 158 meters per second speed. So we have to fire these engines in this mode to it's about 690 seconds. It is fired. This is called a rough braking zone. It slowly, the speed is drastically reduced, and it will. This is called the attitude hold. It will see whether the speed is maintained 358, 336 within a narrow band of design margin. It will be checked. It is held in the same phase. Then fine braking. You can see here it is in horizontal mode. Then it is made vertical. Fine braking phase. Slowly it is brought from 336 meters per second to almost 0 meters per second speed in this phase. Then it will have a vertical. You can see here the lander has been turned from horizontal to vertical. Then it will slow down, slowly reduce from this 1300 meters onwards. It will slowly, controlled way, it is brought down, and it will do hovering here to check whether all the internal place is fine. There are no boulders, no craters. Then it will have a smooth landing. So in the last phase, in the 4 kilometer by 2.4 kilometer area, so it will land in this zone as expected. So this is the landing area. It look for like this. So this is the area shown 4 kilometer by 2.4 kilometer. Anywhere in this region it can land. You should not land on this where there's a crater here or a small crater here. You should not land there. It look for this. This is the endpoint area. This is the flyway path. This is the photo taken by orbiter of Chandrayaan-2, and even this Chandrayaan-3 land also has taken this photograph, same place, and it is matched with the pattern already stored on the surface. I mean, in the memory of lander, it will match, and then once it matches, it knows it is at the correct place, and it will go and land there. So now, after going to moon, we should do some experiments. Otherwise, no point in just saying we have gone to moon. There should be some useful experiments which will help both India and all countries for future days. So several experiments are planned on lander. There are 4 such experiments on. It's called payload. Some experiments. One is this CHAST. It's called Chandra Surface Thermophysical Properties. It carries out the measurements of thermal properties of the lunar surface near polar region. So what is the temperature? Whether it is conducive for life? Whether water is there? And what is the composition of the soil, whether it is magnesium, calcium, potassium, carbon, whatever it is. All the thermal properties are found out here. And this is the LRA, this is a laser spectrometry array. This will help for future landers also, future missions if they want to plan. It will like a torch which is kept there. It's a laser spectrometry array. It will give accurate positioning of the measurement of lander on lunar surface by future orbiters. So next time when our orbiter, Chandrayaan-2 orbiter goes there, by looking at this, we know where exactly this Chandrayaan-3 lander has landed. That will be, it will help in, it's like somebody holding a torch on the surface of moon. I am here. So let's say somebody is landed here, and it will be having a laser source. It will reflect. If you send a laser light towards that, it will show here I am. So that helps in finding out where exactly the lander has landed. And this is the Ramba, this is the probe. I will show subsequently where it will make a hole in the surface of moon, and it will check the ions and electrons and check the density and how it changes with the time. And this is the instrument for lunar seismic activity. Like we have earthquakes on the surface of moon, sorry, Earth. So on the moon, it's called lunar quakes. So it will check whether whether any volcanic activity is there on the surface of moon, and what is the structure of that crust. And once when the volcano happens, so the core it comes out. Here on Earth also we have seen whenever there is a volcano, the core of the Earth comes out and falls like a lava. So here also that it will check whether what is the core. We will know by doing this experiment and check whether any volcanoes and all happened there, any earthquakes, lunar quakes happened on the surface of moon. So on the rover also some experiments are planned. This is called LIPS. It is a laser-induced breakdown spectroscope. It will measure the composition of the soil of moon. There is magnesium, aluminum, silicon, potassium, calcium, titanium, iron, like that. What is there around on the rocks? We are not planning to bring back any sample from moon, but there is a spectroscope which is mounted on the rover, which will take this sample of lunar soil and do spectroscopy and send the data to lander. From there, it will come to Earth. And there's an alpha particle X-ray spectrometer. It checks the chemical composition and indirectly infer the mineralogical composition to further enhance. So there are two spectrometers. One is LIPS laser induced, second one is alpha. So here you're using the alpha particle to do the spectroscopy to check what is the surface, what is the composition of the lunar surface. And another one is the propulsion. Now propulsion module work is already over, but now it is having one payload. What it does is, it's called SHAPE. It looks at Earth and see, this is the Earth. If somebody from moon, if you look at Earth, what you will see? So it will capture the properties of Earth. So if Earth is having, it's having mountains, it is having oceans, desert is there, forests are there, polar regions are there, snow is there. So how it will look? Let's say if you have to find out whether on the Mars or some other planet life is possible, we should look for signatures. Let's say you want to look at mango or custard or orange, how it looks, what is the color, what is the composition. Coconut is hard, whereas fruit is soft, like that. From a distance, you should be able to find out how it looks. So to find out how Earth appears, and it will do this in this near infrared wavelength, it will study the Earth to find out signature, so that you can apply the signature on some other planet to know whether life is possible on some other planet also. So this will help for future missions to Mars and other planets also. So these are the different experiments already told. This gives final details of that payload, which is already sitting there. So already these things have been covered. What is the principle of this? Actually, time is running out. I will run through quickly. It gives more final details of all the payloads. So now, as I told earlier, this is the moon, and this is looking from pole. So this is the area where this is the south pole of moon. Here only we have found possibility of water in using Chandrayaan-3 itself, 2008 itself. This was done. So this is the view taken from the polar region. So our Chandrayaan-2 planned landing site was this. Chandrayaan-3 landing site, proposed landing site is this. It will go and land here. If you were to look at from here, it's about 69 degrees latitude south here. So if you were to look from pole, these are the latitudes. This is about 70 degrees latitude ring. It will land there. So this is the area identified. So here, a lot of bombardment by asteroids and comets have happened over 4 billion years. So here, by using the Chandrayaan-3 spectrometer data, you can find out what is the composition of those things, what is the surface of, what is the material property of surface of moon, all those things. So I will show here what was observed by our lander image on 17th. Is the audio held?
No, sir.
You did not hear the sound?
No, sir, we can't hear the sound.
1 second, I will play it back. Now is it heard?
Yes, sir. Now it is audible.
Yeah. Here you can see the surface see these are the boulders. And if you saw earlier, there are some, you see if you, so if the rover goes somewhere here, it will not be able to generate power because the shadow. And it's not later also. This is the actual image of moon taken by Chandrayaan-3 lander, and this has been already taken by Chandrayaan-1, Chandrayaan-2 orbiter. So this data is compared to ensure that data match is there, and we'll have a identification of landing site, and we'll have a successful landing there. So now coming to this, we'll briefly go through, give the details of Chandrayaan-2, Chandrayaan-3, what is the difference. So it took, depending on, I told you, we have to land on the start of lunar day, 23 days. So that's why it took 48 days for Chandrayaan-2, whereas here we have gone in 42 days. And the location is close to 69.36 degrees latitude and 32.34 degrees east longitude, close to South Pole. This is where the Chandrayaan-3 landing is possible. And the life is 14 days, as I told earlier. When the moon, the sunlight is falling on the surface of moon, 14 days, that is 14 Earth days is equal to 1 lunar day. So that is the life of lander. Subsequently also, we have some schemes to revive once the moon comes back to, lander gets the sunlight. So that's all bonus. So the design life is now 14 days. So now I'll show Chandrayaan-2. It shows, it has some videos. So I will, you can see Chandrayaan-2, what happened. It is more or less same to Chandrayaan-3, except for the propulsion module. Chandrayaan-2, Chandrayaan-3 are identical, and here lots of, I will show Chandrayaan-2 mission profile. This is the propulsion module, which is tested. This is the lander, and it's individually tested. This is the model of Rover. And these two are put one above the other, and then the heat shield is assembled, and it's launched by the rocket. So the rocket launches the satellite. This is the surface of moon. These are the surface of moon. And here they are separated, you can see here. And this lander will go and land on this surface. And the communicate Earth using the antenna. And this is the rover. After something, it will continue. Wait.
India's heaviest launch vehicle GSLV Mark 3
Chandrayaan-2
will launch prestige in technology. 50
Chandrayaan-1. India's Chandrayaan-2 is all set to be launched by ISRO in July 2019 using GSLV Mark 3 M1 launch vehicle. This three-stage rocket is the heaviest vehicle built by ISRO and has been selected for India's prestigious moon mission due to its reliability, versatility, and payload carrying capability of 4,000 kg. Weighing around 3,850 kilograms, Chandrayaan-2 has three modules: the orbiter, the lander named Vikram, and the rover named Pragyan. Once in lunar orbit, Chandrayaan will deploy Vikram, which will make precise, safe, and soft landing on the moon by September 2019. On landing, the rover Pragyan will deploy to perform mobility and scientific experiments on the lunar surface. The rocket will inject Chandrayaan-2 in the 170 by more than 38,500 kilometers Earth orbit. Subsequently, following a phased maneuver of 5 Earth burns, its orbit will be raised to 105,292 kilometers. The spacecraft will then be nudged into the lunar transfer trajectory. From here, the Chandrayaan will take few days to arrive in proximity of the moon. The spacecraft's liquid apogee motor will be retrofired to insert it into a lunar orbit. Gradually over a few days, The spacecraft will be brought closer to the moon in 100 by 100 kilometer circular orbit through 5 lunar burns. While the orbiter will continue in this orbit, Vikram will separate and deboost to 100 by 30 kilometers lunar orbit, where it will remain for 4 days. On the 4th day, Optical High Resolution Camera Payload OHRC onboard orbiter will be turned on to scout for a suitable landing site in the lunar South Pole region. The images taken will be transmitted to Earth and processed, after which the landing site map will be uploaded in Vikram prior to its powered descent phase. Lander will hover at 100 meters above the lunar surface and gradually begin its descent.
Here you can see, you saw now that, surface of how the
Once Vikram lands, the rover Pragyan will deploy. The payloads of Pragyan and Vikram will then be turned on and start collecting information on lunar topography, mineralogy, elemental abundance, lunar exosphere, and signatures of hydroxyl ions and water ice. The mission life of orbiter is 1 year, and that of Vikram and Pragyan will be 1 lunar day, which approximately equals 14 Earth days. Chandrayaan-3 will attempt to answer questions on yet unexplored lunar surface and open up possibilities of using the moon as a platform for further exploration of the solar system and beyond. With this, India reiterates its prowess in space technology and its commitment to humanity.
what you saw was the presentation of Chandrayaan-2, but Chandrayaan-3 is similar to that with all the improvements I told earlier. So this is the Bharat's pride. It's really all Indians should be proud of this Chandrayaan-3 mission. Thanks. Yeah, that ends my presentation. If anybody has questions, I can take it if time is there.
Thank you, sir. So who have questions can raise your hands. I will unmute you to ask questions.
Go ahead.
Yes, hello, sir. That was a wonderful presentation.
Thank you.
I was asking you about, we can see that it's
One-
mission is,
1 second.
yeah, sure.
Yeah, continue, please.
Yes, so my question is not, it's, I have a few questions. We can see that already that this mission is already revolutionary, I would say. Starting with Chandrayaan-2, have been since I've been tracking on Chandrayaan-2 for the the past, from the past, I've realized that we have had the required, you can say, collaborations, right, with some sources mentioning the Russians in collaboration with ISRO for a previous design of Chandrayaan-2. So could you please elaborate on that as well?
I would like to know about collaboration between Russia and India.
Yes, for a previous
Uh,
mission on Chandrayaan.
Yeah. See, Russians had several landing missions to Moon more than 50 years ago, and their last Lunar 25 was in 1976. So after we launched our Chandrayaan-3, they also launched this Lunar 25 about 10 days back, and that lander is called Lunar 25. So after our Chandrayaan-1 in 2008, we had a collaboration with Russia where they were supposed to give this Lunar 25, which was launched now, to ISRO, which has a nuclear power source, RTG. That's how they're able to have a 1-year mission. So, but there are some, they had a unsuccessful landing on Mars, and there were other reasons. So because of that, they did not give the lander to India. So we developed our own lander, so that that's how Chandrayaan-3, we have Chandrayaan-2 and Chandrayaan-3. We built our own, developed our own lander, and we launched them.
Okay, and second question, we have seen the lifespan of 14 days with Vikram and Pragyan. So it's a somewhat type of history with space flight that when something starts, it usually stays a bit longer than expected. So what are the measures taken with this system to stay as one type of system, as well as try to keep the area, you can say, safe with all the new missions and exploration? So basically, in a short way, what is the ideal way to regulate its mission and lifespan?
Now, presently, we are running on the solar panels and rechargeable lithium batteries to power our Chandrayaan-3 lander and rover. So now, our like similar to Department of Space, there is a Department of Atomic Energy, DIE. So BARC, you would have heard, Baba Atomic Research Center at Mumbai. So they are collaborating with ISRO. Future, we also will be having our own RTG to power the lander and rover, so that in future missions, we'll have a source which will not be limited by sunlight. We can have a longer life. So that will happen sometime in future. Yeah, next.
Deepthi, you can ask a question.
Good evening, sir.
Good evening.
Sir, I have a doubt.
Go ahead.
Sir, did Chandrayaan-2 fail?
Yeah.
Sir, but what is the reason for failure of Chandrayaan-2?
I told no. See, there was some redundancy was not there because the area identified was less. It was only 0.5 kilometer by 0.5 kilometer. And there are 5 engines in Chandrayaan-2 lander, and in the Chandrayaan-3 lander we have only 4 engines, and a lot of guidance electronics has been put to test, and new sensors have been added here: altimeter, horizontal velocity, and vertical velocity check. Those things. These things could not be done in Chandrayaan-2 time frame, and it went to as low as 1.5 kilometers. Then instead of slowing down, it went faster. So that's how it, because the target was still away, because the target area was very small, 0.5 by 0.5 kilometers. It's like you are you want to reach Majestic bus stand, but still you are somewhere near Vidhan Soda. What you will do? You will rush fast now. So the Chandrayaan-2 Vikram was not close to the intended landing area. So it of reducing, it went past, and there was no closed loop thing to check that. And we could not control from anything from Earth. Everything has to be done on orbit. So all these things have been improved in Chandrayaan-3 to take care of those things don't happen. Yeah.
Sir, we have a question in chat box, sir, from Shrikant. Sir, can you explain about that row pitch and yaw in Chandrayaan-3 in role of landing?
I told no. See, it has to continuously control all three. So it should be stable. One is it has to have a vertical thing where it should not be at an angle to the surface of moon. So we have to ensure that it is parallel to the surface of moon, and the solar panels are genetic power, and wherever required, battery will also discharge required, and the speed is regulated, and it will, when it's hovering, it has to maintain all three roll, pitch, yaw control, so that it will stay there, do a assessment of the surface of the land. There are no pits, no boulders or those things. Then you have to check with the already pattern which is there on the previously photographed photos, then have a successful landing. So all these things, it will be done by the guidance electronics, which is part of the lander. Yeah. Rashmi, you can...
Okay, thank you, sir. Chirag, you can unmute yourself and ask your question.
Hi, sir. Good morning.
Yeah, good afternoon.
So, good evening, sir.
Yeah, good evening. Yeah, go ahead.
Sir, when you said when we can travel to moon also, we can go on moon.
Yes.
When the meteoroid crust on Earth, it catches fire by the gravity force. When we will come again to Earth, how cannot rocket catches fire?
I didn't get your point. You are telling when the rocket is going, whether a meteorite can hit. Are you asking that?
No, sir. No, sir. When the meteors crashes Earth, by the force, it catches fire, sir.
Meteorite, huh?
Yes, sir.
See, on the surface of Earth, several places meteorites have hit. There are, you can go to Google and see, it has made lots of craters. Some craters have fallen in India also. Those sites also are there. They don't happen once in a way. They're all every day it will happening. But what happens is, because Earth has a atmosphere, it will all get burnt when it's entering. It will all break into small pieces. And daily it will be happening. That's how all this International Space Station, some of you can see actually satellite space station in the evening. You can go to Google and search when it is passing over your area. Let's say Bangalore you want to see. When the International Space Station is going over the in the sky of visible from Bangalore, you can go and see in the evening, either evening between 6 and 7 in the evening when the sun is setting, or early morning also you can see. I will give a task to all students. Please take help of your parents and teachers to look for ISS. Actually, you can sight the International Space Station from Earth, so from your own place. So what that also will be getting lots of meteors and all. They will do some lots of debris are there in space. Now when we launch a rocket also, some debris are created. So those things are avoided. So it is not a regular event that it will come and fall on Earth daily.
Okay, thank you, sir. Rashmi, can you ask your question?
Thank you, the hostess. Good morning, good afternoon, Mr. Srinivasan. Rashmi from the US. India is the only country to have landed on the South Pole with Chandrayaan-1. And if yes, have we found the temperature at the South Pole and the variations in the temperature?
No, we are yet to land on the South Pole. Chandrayaan-1, what we did, we took a photograph. We did lots of studies because nobody was looking at South Pole. Their area of interest was equator. Even the Apollo missions, all Apollo missions landed only close to the equator. See here, you can see, no, this is the moon, all these things, they all landed here only, close to equator.
Yeah.
So whereas India, this is the, you can see here,
Yeah.
the polar region. This is a photograph taken by Chandrayaan only. You can see water molecules are seen, I mean, water bodies.
Yes. Yes.
Not
Did
exactly
they
like
send temperature? Did they take temperature readings and communicate it to ISRO?
No,
Did-
we didn't land. We didn't land there. Chandrayaan-2 were planning to land.
Okay.
Chandrayaan-3 were going to land, and Russians also are landing there. They also will do their own studies. We also
Okay.
do our own studies, and that will help everybody in future.
So as of now, nobody has temperature readings of the south pole of the moon, correct?
No, nobody has landed there so far.
So hopefully, because between equator and the south pole, the temperature readings will be very different. US landed all the times on the equator.
Close
We
to
have
equator.
temperature,
Yeah.
we have those temperature readings, and the variation between noon and night is drastic over there. It's boiling temperature at noon and negative 220 degrees.
Minus 130 degrees. It's dark.
So
Yeah.
how do you, whatever material you're using, not knowing the temperature, how did you decide? Basically, you must.
No. We are indirectly we have the temperature, but actual samples have not been taken because nobody went there first.
Okay, so you're estimating the temperature. You're guessing.
It's estimated. It's close to the actual, but if you go, let's say you want to study the volcano, you have to get a sample near volcano. If you get a sample in desert, it will be different. In Amazon forest, it will be different. In hilly region, it will be different. The forest, it will be different.
Sure.
So now we have to go there and study. Because lots of craters and those things are there. So that we have to go there and get the sample and do this using spectroscopy. Alpha and X-ray, the two pillars are there. Now we'll check it.
Thank you. Sir, I have one more question before I hang up. They said that the high thrust was one of the reasons, limitation of software was the second reason, small landing site was the third reason for Chandrayaan-2 failing. You explained very well how the small landing site has been handled with. Did you explain in your presentation how the limitation of software and error detection was also taken care of? Maybe I missed it.
Yeah. We have introduced additional sensors on this Chandrayaan-3 lander.
Okay.
So it will give the horizontal velocity, vertical velocity, and altimeter. So that will give the height, relative height, every time it's moving with respect to surface of the moon, what height it is there, and do the corrective action to reduce the speed or increase the speed to have a smooth landing on the surface of the moon.
Thank you, sir. Thank you, host.
Yeah, thank you.
Thank you, ma'am. Thank you, sir. Sir, we have a question in chat box, sir. So what is the total power budget of Chandrayaan-3 and what are the total subsystem involved in Chandrayaan-3?
I think
Not money, power budget, sir.
Power budget, I will show this screen 1 second. I will share it. Yeah, I can see here the lander generates about 730. Yeah, first I will show the propulsion module. This is the propulsion module. A lander, it generates about 738 watts power in winter solstice, and rover generates about 50 watts of power. Got it?
Yes, sir.
Hello? Yeah.
Yes, sir. Yes, sir.
This is the power generation of lander 738 watts and rover 58 watts. These are the already explained that.
Okay, sir. Thank you. Hope no more questions are there.
Yeah, once again,
I will wind up this program.
Yeah, next I will tell you what is in store for India after this. So now, after this successful landing Already our Aditya satellite has been moved to Sriharikota, so that will be launched sometime in first week of September. So you would have heard of James Webb telescopes, no? So you can do
Yes,
Google
sir.
search. Yeah, there are two places where to look at sun. It not to go near sun. It will be at a distance of at a location called L1, where it will be parked and looking at sun all the time. And this Chandrayaan-3 is planned in 2024. And this is a NISA project. It's called a NASA ISRO radar imaging satellite. So these, along with NASA, ISRO is building for a global use. And this is called SpaceX. So if you want to dock with space station, you should evaluate the docking mechanism. That is the satellite is ready. That will be experiments will be done to check whether you can dock with the space station or two satellites in space also. Then there is one Venus orbiter mission that's also planned in December 2024. And next is this reusable launch vehicle, where we are going to use the rocket multiple times to reduce the cost, so that area could do. And the biggest thing is our Gaganyaan project, where we are going to put two astronauts in space after testing some test flights and all the field or abort tests. We will be having a human in space in another 1.5 years to 2 years. So you people, you know who was the first Indian to go to space? Anybody can answer? Hello. Yeah. Okay. Now we'll go to this is the Aditya payload, where it will be launched by our PSLV. It will be Lagrange point L1. It will be 92 million miles from the sun, and it will be continuously looking at sun, and it will get the data to Earth. Then see, you can see here how the Aditya is launched to. It is a mission to sun. This is a NISA, it's a NASA ISRO radar imaging satellite, where we'll have a 12-meter unfoldable antenna. It will look for images in all conditions. That's why it's called radar imaging. It will help whether you have floods, earthquakes. The payload is built by America, that they handed over to India, and tests are in progress in ISRO Satellite Center, Bangalore, and that will be launched by ISRO by using the GSLV Mark III rocket next year. It is for global use. You see here, once satellite is going around Earth, this satellite will do the imaging of Earth and look for vegetation and natural calamities, flooding, all those things. And this is the Gaganyaan, where we'll be putting two astronauts in space. There will be two modules. One is the crew module, another is the service module. Then it will go around Earth. It will stay there for about 5 to 7 days in space. And the food for astronauts has been developed at our Mysore facility. So they will stay in space for 5 to 7 days. Then this service module will separate. Then using parachutes, this test was successfully done in Gujarat last week, where the very high powerful parachutes tests were done. And before that, we'll be having some test flights to check all things are working fine. You can see here how the satellite rocket is launched. The Earth is going, and they will go around Earth for 1 week. Then they will successfully come back and land on the sea. Yeah.
Hope no more questions are there. Okay, sir, the session was so informative, sir. Thank you for the knowledge given by you. Thanks from all the participants. Thank you, sir. I will wind up the program.
Yeah, it was nice interacting with the students. I hope more people will have interest in science and pursue a science career apart from engineers. All of you tune into Chandrayaan-3 successful landing on 23rd August at 5:47 p.m. Thank you.
Thank you, sir.